will be able to tell us much about manual DNA extraction principles, the reagents and the equipments that are needed, the step-by-step processes, the common errors, and also the best practices. These are some of the areas that we'll be able to understand this wonderful afternoon. And also be able to, the speaker will also be able to answer most of the questions that we will raise out of this discussion. Otherwise, it's also important to introduce myself, and my name is Arthur Imari. To those who have not been with us under the LMSK webinar presentations, today's moderator and our presenter, who is a renowned scholar that works with the Nairobi West Hospital. He's a senior medical laboratory technologist. His name is Robert Rono, and he will also be telling us much about his biodata that maybe I haven't talked about. He'll be free to share. Otherwise, it's also important to also share with you that we also have the LMSK CPD Learning Hub that you can also join this presentation through. You can also watch most of the videos in our Learning Hub at your free time. You can also join our WhatsApp community. We have different WhatsApp groups. We also have a WhatsApp channel. You can also subscribe to our YouTube channel. You can also subscribe to our Facebook pages so that any information, any article that we are able to share, you'll also be able to access. We also urge members to join and register as LMSK members so that you will be able to get much of information from our website in terms of research and in terms of other activities that come with our website. Thank you so much. Our members we have a good number now, and I think our speaker can start. We also urge that to our members who are still registering, ensure that you update the right information so that when we are uploading your CPD points in your portal, then it's easy for you to get the CPD points. Otherwise, if the information you give us when you are registering for these webinars are not tallying with the information at the KMHDTB board biodata, then most of these CPD points will not be uploaded successfully. So we urge you that whenever you are registering for this presentation, you make sure that you do the right thing so that the points, you are able to get the points. Otherwise, I hope our presenter is able to hear me. Hi, good afternoon, Mr. Rono. Are you able to hear me?
Hi to Ada. Good afternoon to you. I can hear you very well.
Thank you so much. I think you are good to go, but we also urge that you can say more about yourself in terms of medical laboratory science practice in this country. There's a lot of information that have not shared that can be of great help to the medical lab personnel in this country. So I urge you that you don't be mean to your biodata. I know you have a very rich biodata. Just share so that many of our members who are here can also get to connect with you so that we keep sharing knowledge. Otherwise, without wasting more time, allow me to bring you in so that you can continue with this webinar presentation. Welcome, Mr. Rono.
Thank you very much again once more, Ada. I really appreciate. Thank you for your clear introduction. And without wasting my time, okay, as you have said, exactly, my name is Robert Rono. I think the details you have said clearly. And I think we will go through to our discussion today. to our topic of DNA extraction. And as these learning objectives as concerned, you can, by the end of this session, participants will be able to explain the principles of DNA extraction, compare the common DNA extraction methods, identify clinical and research applications, recognize common pitfalls and quality issues. I can give you brief history of DNA extraction. It says that in 1869, a scientist called Friedrich Miescher first isolated DNA from the white blood cells using the alkaline extraction, marking the birth of DNA chemistry. In 1940s to 50s, there, protein removal methods development of enzymatic digestion and organic extraction, that is phenol chloroform, improved the DNA purity. In 1970s, molecular biology era standardized protocol enabled recombinant DNA technology and early polymerase chain reaction applications. In 1990s, spin column technology, introduction of silica membrane-based extraction made DNA isolation faster, safer, and reproducible for clinical laboratories. In the year 2000 to present, automation and high throughput method, magnetic-based, bead-based extraction supports automation, minimal hand-on time, and larger scale testing, like for example, the pandemic of COVID-19 diagnostic. So, why DNA extraction matters? We ask ourselves. Foundation for this was for polymerase chain reaction and real-time polymerase chain reaction. We have also the genetic testing. We have oncology diagnostics. We have infectious diseases such as COVID-19, MTB, Mycobacterium, CMV. We have Epstein virus, varicella zoster, herpes simplex 1 and 2 virus, and also this one applies in forensic medicine. What is DNA extraction? Let's definition of DNA extraction. It says that isolation of DNA from cells or tissues by removing proteins, lipids, and other cellular components. The key goals is that we need high purity and integrity DNA molecules. Also adequate yield. This the source of DNA can be obtained from various DNA samples. One we have, you can use the whole blood samples, buccal swabs, tissue biopsies, bone marrow, formalin fixed paraffin embedded, microbial cultures, sputum, urine, and the clinical note here, sample type affect the method of choice. Basic principle of DNA extraction. We have cell lysis, removal of proteins and contaminants, DNA precipitations or binding, and then we have step of DNA elution. This is an example of DNA spin column extraction. There is a flowchart you can see, members, colleagues. I think that diagram is clear for you to see what is happening in spin column extraction. You see there, you see that we have microcentrifuge tube, spin column. We have the procedure goes in that manner, whereby there is binding, there is washing, and finally elution. In step one, we talk about the cell lysis. The purpose of cell lysis is to break open cells membrane and release the depoxyribonucleic acid. The chemical lysis, use of detergent like SDS, sodium doxycyl sulfate, This disrupt the lipid membranes. We have also enzymatic lysis. We have what is called proteinase K, which digests the protein. The lysozyme also is effective for bacterial cell wall. Mechanical lysis, this one is the grinding and beating mainly for tough tissues. And remember that there is caution there, excessive lysis can shear genomic DNA, affecting downstream applications. Step 2, there is what is called removal of proteins. The chemical called phenol chloroform extraction, which lyses proteins, lipids, and other organelles, leaving behind two layers of solution DNA in the upper aqueous phase and the impurities in the lower organic phase. And then DNA is transferred to a clean microcentrifuge tube. Salting out, that is sodium chloride and ammonium acetate is used. This uses high concentration salt to precipitate the proteins. The case of silica membrane binding involves 2 to 3 washing steps to purify the extracted DNA and remove impurities. DNA selectively binds under high salt condition. Clinical reference protein contamination inhibits the P polymerase chain reaction. As we go to step 3, where there is DNA precipitation and binding, the alcohol precipitation, that is the ethanol and isopropanol, the extracted DNA is precipitated to agitate the DNA. The column-based binding, the extracted DNA is bound to the silica membrane, which has a net positive charge. Magnetic bead technology, silica-coated magnetic beads bind to the extracted DNA, thereby extracting DNA from the impurities. Often the above methods are followed by centrifugation process using the refrigerated centrifuge. I know most of you know about this refrigerated centrifuge. That's normally at the temperature of 1 to 4, and it has a standard. There is a standard speed for spinning, that is at 1100 gravitational force. This leaves an extracted DNA in form of pellets, needing to be dissolved to solution elution form. The washing steps, multiple wash buffers remove the salts, proteins, and inhibitors. Inadequate washing leads to low purity and PCR inhibition. And step 4, we have the DNA elution. In elution, the elution buffers or the nuclease-free water. Remember this, the elution buffer normally are nuclease-free water. This one dissolves the precipitated DNA to solution form, ready for downstream process or storage. Volume affect concentration. The higher the volume of elution buffer, the lower the concentration of the DNA. And if your DNA is for storage, normally it's recommended that it's stored at -20 or -80 degrees centigrade. So here we can see, as you can see, a table there where it shows it's an overview table where it shows the methods of extraction. We have the first method of phenol chloroform, the spin column, and the magnetic beads. So the course, as you can see there, is indicated low, moderate, high. The purity again there, is as you require the high, we need the high purity DNA. The chloroform, you can see it's high. The spin column is high. The magnetic beads also is the highest, it's very high. Speed, you can see as follow. And you can proceed down there. Phenol chloroform method. This method, it has some advantages and disadvantages. One advantage of, or two advantages of this phenol chloroform method is that it makes high yield DNA. It also, the DNA becomes intact. The disadvantage of it is that this chemical are toxic. They have a corrosive and harmful effect to if handled directly. So it's also time consuming and it's not ideal for routine diagnostic like our laboratories. Most of our laboratories are for routine diagnostics. The case of spin column paste extraction, one is the most common in our clinical laboratories, and this one applies in what's called one of them is silica membrane technology. This is rapid and it is also reproducible and is compatible with polymerase chain reaction workflow. And for the case of the magnetic bead based extraction, this one is normally friendly, automation friendly. It yields high yield of DNA extracted with high purity, which mostly is used in COVID-19 testing. We have also it can be used in molecular oncology panels for cancer diagnosis. The DNA quality assessment. Uh, Here, when we talks about quality assessment, the reason here is that we need to ensure that our DNA that we harvested are of high quality. There are methods that can be used to assess whether your DNA are of high quality. There is machine called spectrophometry, and this one normally is it works in a simple sample absorbance is measured in a wavelength that is 260 nanometer is the wavelength at which DNA and RNA absorb the UV light due to their nucleolide bases, while the one for 280 nanometer is the wavelength at which proteins absorbs the UV light, mainly because the aromatic amino acids, that is the tryptophan and thyroxine. Second, we have low, that is A260 and A280, and the required, if this one indicates, if it is less than 1.8 in your machine, it indicates that protein or phenol or geotrophic salt contamination, and this leads to PCR inhibition, that is poor enzyme activity inconsistent, and this one can cause the CT values in inconsistent, can cause consistency in CT values in the real time PCR. There is what's called high to A260, and if this one is greater than 2, it suggests that the RNA contamination, which can falsely elevate DNA concentration readings. The ideal normally is actually should be 1.8. That's when you realize that you've achieved your quality DNA. Now, the common problems that are normally faced during DNA extraction. One is the low yield. This one is caused by the poor lysis or sample degradation. Second is the poor purity. You find your DNA might be poor, and this one is because the protein or phenol, there was phenol or protein contamination. This one, there is what's called uh, PCR failure, and this one is due to inhibitors present due to lack of the use of sterile PPEs. And in most cases, it's recommended that when doing extraction, most people should be using the sterile PPEs. Like, for example, the free bordered gloves, that one is mostly recommended to be used, and also ensure that while performing all these tests you have to ensure that all is done under the biosafety cabinet. We have clinical applications, the genetic disorders, that is PRCA, thalassemia, that's where we can apply the DNA. We have oncology, next generation sequence, tumor profiling. There is also case of infectious diseases like TB, PCR, HIV PCR, and the COVID-19 PCR. There is also the transplant medicine that is under HLA typing. We have a case example or scenario where suppose we have poor PCR amplification from any sample resulting in erroneous results. What would be the possible cause of this error? As we ask the question yourself. So the discussion is DNA fragmentation due to prolonged lysis step during extraction. There might also DNA process might be there was a poor washing during removal of proteins steps. Such errors highlighted above, the need of specialized commercial extraction kits are a move away from the manual extraction. So the best practices in clinical labs, remember these best practicals is what we are recommended all of us as colleagues, that standardized protocols should be put in place, proper sampling or handling. When I say proper handling of sample, you know very well the phases like the pre-analytical phase, the analytical phase, and also post-analytical phases. So I think I will not talk much about that. There is also the use of sterile bordered free gloves, the one I had mentioned, because if we use the bordered gloves, this might cause some contamination and also might interfere with the amplification. There is also internal quality controls, like I had talked about earlier, about this machine called spectrophotometry, which is normally used to check your quality of DNA, whether you have achieved the right volume. You also measure that using, you also need to be using internal QC concurrently during automated extraction method or even manual extraction method. So also, the best practice we have to ensure also documentation such as the CME compliance, read your SOPs proper and understand. And also maybe if in case you are not sure of what you are doing, you can refer to the manufacturer insert. The key take home messages now. DNA extraction is critical for accurate molecular diagnosis. Method choice can depend on sample and applications. Quality control is always essential. So you can get our reference from the World Health Organization Molecular Diagnostic Guideline, CLSI standards, principles and practices of DNA analysis, laboratory manual for forensic DNA typing, comprehensive bench level, protocol and explanation of DNA extraction, and maybe the downstream DNA analysis methods, Spring Lambert Protocol Handbook. Also can refer to our advanced topic in forensic DNA typing, methodology, and chapter on DNA extraction and quantification, discussion strategy, contamination issues, and forensic lab quality control. That's it all. 2020 principle and practices of DNA analysis. Thank you. So other, I think members, we are end to our discussion. Maybe if there is any question, we can back to you, Ada. Maybe if you have any information regarding our discussion.
Yeah, thank you. Thank you for this wonderful presentation. I know we are going to get so many questions that are going to come so that we are able to share. We have Mary Karimi, who is requesting so that you share the slides for reference.
Okay.
I think Mary, you'll get in touch with us so that we can help you get those slides. We have Benjamin Opio who has a question. And so the question is, kindly elaborate how to remove the contaminants like proteins and RNA from DNA sample extract. Maybe you can answer that as we wait for other questions to come. Back to you.
Okay. Obio, come again with the question. Ada, repeat again your question.
Yeah, let me check. Let me check for the question again and do a repeat. We have Benjamin Opio, and the question is, kindly elaborate how to remove the contaminants like proteins and RNA from DNA sample extract. Back to you.
Okay. Yeah, thank you very much, Opio. As we had discussed earlier, the removal of proteins from the from the samples is normally done through the downstream process of extraction. Like in the first place, we had talked about the DNA molecules. The process of lysis, as I told you, cell lysis involves the removal of cells. As you can refer to step 2, I will share with you the slides. The step 2 was about removal of proteins. And in this case, there is a chemical we discussed that is called phenol chloroform, which lyses the proteins and also lipids and other organelles, leaving behind two layers of solution, that is DNA in the upper aqueous phase and the impurities in the lower organic phase. Then the DNA is now can be transferred to a clean, sterile microcentrifuge tube. I think I've answered Bernardo Pio question.
Okay, let me check from another. Yeah, some Bernard Opio also is asking, what
Yes.
is RNAs? What is RNAs? What is RNAs?
Yes. Okay. RNAs, as you know, okay, the difference between RNAs, that is the ribonucleic acid, as normally is a negative charge molecules in a cell. I hope I've answered the question. Ada, did I answer your question clear?
Okay, thank you. Let's look at another question. Yes, Benjamin has made feedback and he says, you've explained the protein removal. I am interested in the removal of RNAs. Are you able to give an explanation for that? He's interested in the removal of RNAs.
Okay. So in the case of the RNAs, normally there is what is called silica membrane, silica membrane binding. In this case, we normally have different types of silica membrane. It comes from the manufacturer's specification that indicates the spin column is specific for RNA. And there is also in manufacturer's instruction when you are purchasing, there are spin columns specific for RNA. So when you use each, this one will specify and you will be able to collect the right molecule, whether you will be in need of the DNA or RNA. I hope I've answered your question.
Thank you so much. We have Simeon Letting,
Yes.
and he says, kindly come up again and explain to us why DNA extraction method depends with the type of samples. Back to you.
Okay, thank you very much, Simeon Leti. Uh, the reason why DNA sample uh, is affect the method of choice, I can say, for example, in the whole blood cells sample, that is the whole blood sample which are used. Remember, the cells are present in quantity compared to any other specimen, like for example the sputum. If in case we were running an example, Mycobacterium tuberculosis PCR, in this case, remember in most cases these MTB bacteria is normally there is areas known where we can actually use the, the biopsy. For example, okay, let me come again. The reason why sample type affect method of choice is because if in case some other specimen like sputum, there is the absence, the cells in the sputums are more or less, so you will find the yield might be low, or the purity might be compromised. I hope letting have answered your question clear.
Thank you. Thank you so much. We have let me see. There was a question we had a good question here. Let
Yes.
me get hold of it, and then yes, we had a question and also a comment from Professor Tom Were. He says, great summary of DNA extraction and application. And then he's requesting for these slides so that the slides can be shared.
Yes.
So I hope we'll be able to share the slides. Benjamin Opio makes a comment again. So the comment reads, we must always understand the type of DNA we are extracting, whether it is a normal pathogenic DNA or plasmid DNA. Again, for RNA removal, we use ribonucleases to precipitate the RNAs. Maybe as an expert in this area, Mr. Rono, you can maybe expand on this comment as we proceed.
Okay.
Or I can repeat the comment.
Just repeat the comment.
Yeah, the comment is, we must always understand the type of DNA we are extracting, whether it is a normal pathogenic DNA or plasmid DNA. Again, for RNAs removal, we use ribonucleases to precipitate the RNAs. Back to you.
Yes, that is very good comment, Mr. Leti. Yeah, the normally in this case when we are extracting the DNAs, whether it's plasmid or pathogenic DNA, okay, the matter we know we are not sure whether this one is pathogenic or plasmid DNA. So our interest in this part is actually to get our to harvest our DNA molecules, which at the later end we will now proceed for amplification. And in application, you will realize that um, is it the CT value corresponding to the type of the type of DNA molecule you are looking for. For the case also of the RNA, the specification also is the same. It's only to follow the manufacturer's instruction for you to get into the final product of your RNAs. So I think letting that comment is good, and most in most cases in our laboratories, you find that many people omit the process of RNA extraction. I don't know why, but it is good to actually learn more about that. Thank you. I hope letting I've answered.
Yeah, thank you. Thank you, Mr. Rono. Let's look at other questions that are coming in. Now, Janet Chepkorir is asking, what are the common causes of sample degradation and poor lysis? What are the common causes of sample degradation and poor lysis? Back to you.
Okay, thank you very much, Joyce. That is a very good question you have asked. That what causes degradation of sample, and as we all know, the sample degradation is in most cases can be caused by maybe poor handling of the sample, like poor storage of the sample. Might be the sample was left in a high temperature environment, and definitely the sample will not be viable or good for process of DNA. And then you talked about also the the causes of poor. Yeah, can say if the wash solution are not done properly during process of extraction. Remember, this one also will lead to poor harvest of DNAs. In other case, also, if samples are not collected in, during the using the right procedure, you find that samples might not be fit for extraction of DNA. Also, the degradation of sample might be caused by poor transportation. Like, for example, we talk about in this case because we were very much familiar with the pandemic of the COVID-19. You can remember if sample is not transported well under transport media, you will find that the sample now reaching the lab will not be good, or it might have been tampered during the transportation. So thank you, Joyce. I hope I've answered that question.
Yeah, thank you, Doc. Let me check on another question. We have a question from Kathiari James, and the question is, how is pathogenic DNA different from plasmid DNA and genome DNA? How is pathogenic DNA different
Yes.
from plasmid DNA and genome DNA? Back to you.
Okay. Normally, when we talk about the plasmid DNA and the genome DNA, for the case of genome DNA, remember that when performing amplification, their master mix reagent that is specific for the plasmid. So for the case of plasmid DNA, And genome DNA, it depends with which type of reagent are we using. So the plasmid DNA normally is always indicated by the manufacturers. Manufacturers, they are normally reagent commercial which are sold, and it normally has the specification whether the one is plasmid or not plasmid. I hope I've answered the question.
Okay, thank you. Thank you. Thank you. Let's look, let me check for another question. Aaron Were, there's a question here from Aaron Were, and he says, I think alteration of pH is what matters in purity. Probably you can explain, you can maybe make a comment on that.
Yes, alteration of pH.
Yes,
Yes,
yes.
yeah, thank you very much, Aaron. That's a very good question. And the alteration of pH usually tampers with the DNA and molecules. And this one also can lead to poor results of or PCR inhibition. Since they recommended their recommended pH as per the manufacturer's instruction, and if the pH is not uh, followed clearly, you might it might lead to the PCR inhibition, or the enzyme activity might be interfered. You know, the enzyme has specificity enzyme reaction, and this one also might cause the inconsistency in the CT values in the real-time PCR reaction. I hope I've answered that regarding the pH.
Thank you. Thank you. Let me check for another question that we haven't answered.
Yeah.
Yes, we have John Otieno, and John Otieno is asking, at what time do we use biopsy to determine DNA? Probably you can, I hope you are able to understand that question better than me. But the question
Yeah.
is, point, at what point do we use biopsy to
Yeah.
determine DNA?
Oh yes. Thank you very much. It's Aaron. It's Aaron. Yeah.
The question is from John. From John.
No, thank you very much, John. They at what time he asked? At what time do we biopsy is used?
Yes, John
Uh,
Otieno has asked, at what point do we use biopsy to determine DNA?
okay, in cases whereby we cannot access to the real the real sample for DNA. It's normal. You remember very well the case of the case of what had happened in Mombasa for these mass graves, which it was being done. The bodies was resumed from the grave sites. These samples were not or majorly taken for a extraction of DNA for them to identify who could be the possible person or a relative for that particular deceased person is to which family. That is when biopsy tissues are normally done for DNA. So I hope, John, I've answered your question. It normally applies when it comes to their disputes cases. Back to you, Ada.
Thank you, Doc. I was going through some of the comments here so that that I get a question for us.
Okay.
Uh, Trying to check on any other question. But allow me to request you to
Yes.
repeat this question.
Yes.
Uh, can you kindly repeat for us why DNA extraction methods depends with type of sample?
Okay. Okay. So
Different
sample.
methods with the types of samples.
Okay. Okay.
Hmm.
Okay. Thank you very much. It was a good question. Normally, you see, for the case of sample testing, if we are looking for example, we want to find out the COVID-19 for a particular from a particular client, the sample type recommended for extraction normally is it comes with the manufacturer's instruction. They say normally, you remember very well that we were using the nasopharyngeal sample and osopharyngeal sample. In this case, we were not using blood neither to check for the COVID-19 PCR. So the type of sample normally is because the concentration of the DNA is normally of high. The yield will be high in certain sample compared to other samples. So that's why if we, in this case, we specific to say that the sample recommended for COVID-19 is the nasopharyngeal or osopharyngeal swabs for us to achieve the 100% or high yield of the DNA from the specimen. I hope it is clear.
Yes, thank you. Thank you. We're getting another question and also a comment, and I'll read it so that you are able to make your comments on it. So, just Fat Kiko Johnston is saying we use biopsies for DNA extraction during mutation analysis like KRAs and BRAFs. You can make a comment on that, Daktari?
Yes, that is great. This is a good comment. In fact, that is majorly recommended. Other, that is a very
Thank
good
you.
comment.
Thank you. And he further says that is just Fat Kiko. DNA extraction does not depend on sample type. All samples can be extracted. Thank you. We have Dr. Kale Bonyango, and he says, what happens when you encounter a pHDNA degraded sample? What happens when you encounter a pHDNA degraded sample? What do you do? Back to you.
Okay, when you happen to have gotten such a scenario, I think it is recommended that we, if it's good, we can you can use another sample, or you can collect another sample to extract for you and ensure that you follow the right procedure for you to achieve the high yield or to achieve the required pH. So when processing all this, ensure that errors are not made, because that one will be one of the disadvantage, and it might lead you to give erroneous results. Back to you, Ada.
Thank you, Doc.
I wanted to also to uh, I
Yes,
wanted
yes,
also
yes. Proceed kindly.
to add regarding to that question. In such cases, there is what is called commercialized extraction. Now, where this manual method we are discussing about has replaced the process of manual extraction, and this normally automation is normally more of there is more of accuracy regarding to extraction. Thank you very much, Atta.
Very nice. Very nice. Um, Let me check if we have any other questions so that we share. I'm trying to see if there's any additional question so that we share. Um, uh, Now, there's a question from David Kaino.
Yes.
And the question is, do we have a rejection criteria for DNA samples? If we have one, you can share this criteria, please.
Okay. Thank you very much for that question. That's a very good question. And the sample for DNA extraction, normally, first you assess whether the sample are transported correctly as per the manufacturer's instruction. If the sample was not transported as per the manufacturer instructions, definitely that is one of the criteria you can use to reject the sample. And then remember very well, obvious, when you reject a sample, you document as per the policy, and also other cases of maybe if there is no clear details of the particular specimen, you ensure that the samples are correctly labeled, matching with the details of particular client. And if they are matching well, you are good to proceed to accept the sample. And if it is not matching, you can as well reject the sample with follow the with documented reports accompanied.
Thank you. Thank you. Yes, another question from Josephat Musioka, and the question goes, how is DNA extracted from nail and hair? How is DNA extracted from nail and hair?
Thank you very much, Mushoka. That's a very good question. DNA from body parts like hair and fingernails. Normally, you follow. Okay, there are so many methods of extraction. We did not go as each and every part, but if the method you are using, if you read the manufacturer's instruction, that the recommended specimen of choice is normally followed. And if it is the hair, First of all, there is a procedure of dissolving the air molecules for you to achieve the required sample. And this, in case you remember, we had discussed about the steps of DNA extraction, where there is the lysis, the cell lysis, the removal of whatever the protein and contaminants, and also there is what's called binding. I mentioned also about another method whereby there is what is called mechanical lysis, where in this case mechanical lysis is grinding or beating mainly for tough tissues. If you remember very well, I discussed about that. And then there is also a case of chemical component of lysis, where we use detergents like sodium uh, dodecyl salvate, which disrupt any of each tissues or lipid membranes of any particular sample to release the DNA. I hope I've answered that for Mushoka.
Yes, yes. David Kaino has gotten your point. Thank you so much. I'm trying to see if we have any additional question in our
Okay.
Q&A section. Um, there's Kathiari James, huh?
Yes.
Sorry. There's Kathiari James, and he has a good question here, which I think
Yes.
we haven't tackled. Let me read it. When doing PCR for gene detection and your sample happens to be contaminated, can the contaminant interfere with the detection considering the primers are specific to the gene of interest? I can repeat the question. When
Yes.
doing PCR for gene detection and your sample happens to be contaminated, can the
Yes.
contaminant interfere with the detection considering the primers are specific to the gene of interest? Back to you.
Yes, thank you very much, James. That's a very good question. Yes, it do. The contaminants do interfere, and in this case, for you to check on the amplification, normally when performing the PCR amplification, you check on your CT values, and normally you when performing the real time PCR, uh, remember your QC, the internal QC. If in most cases, if there is contamination, definitely it will fail. If you proceed and you realize that, and the IC, the internal QC has failed, I don't think you are in a position to proceed and give out the report in which the internal QC has failed, since the internal QC is normally a guide to show you that whatever you are doing, whether during extraction or during amplification, was of quality. So the end point here in this case, the guiding factor is the internal QC for you to achieve. If the internal QC failed, you have to ensure to find out where possible contamination might have occurred. Thank you, Ada. I hope I have answered for James.
Thank you so much. Thank you so much. Yes, I think we've finished all the questions that we had that had been raised.
Yes.
Yes, there's another question that has popped up. So it's the question from Byron Odhiambo, and the question is, how long should a sample for extraction stay? That is when collected and its analysis. how long should a sample for extraction stay when collected and its analysis? Back to you.
Thank you very much, Byron. I know Byron very well. And for the sample storage, it's normally it depends which DNA or which samples are we handling in this case. So for whichever case, if the sample of the swab, like the nasopharyngeal swab for COVID-19, normally the specification from the manufacturer indicates very well that the sample should not stay for more than maybe they specify the time when the sample is collected, and if the sample was collected, there is instruction where the specimen should be stored in. If they say if it is at room temperature, or if it is in 1 to 4 degrees, or if the sample is recommended to be stored at maybe negative uh, certain value. It depends with the manufacturer's instruction, because in this case we have various methods of extraction. So if choice, if the method you are using requires samples to be done within 24 hours, you follow the instruction. Thank you very much, Byron. I like their question.
Thank you. Thank you, Doc. There's a question from Joash Kirwa, and the question is, does centrifuge speed affect the quality of extraction? Does centrifuge speed affect the quality of extraction?
Thank you very much, Kirwa. That is a very, very, very good question from Kirwa. Yes, the the centrifugation speed normally affects the quality of the sample, DNA sample. For example, if your centrifuge is not the type recommended for the high speed centrifuge, which is normally used, because the high speed centrifuge, which are refrigerated, are normally specified to be used during extraction. And in this case also, your SOP or the manufacturer's instruction you have to follow to actually understand that at what speed is recommended for that sample to be centrifuged. A high speed for this refrigerated centrifuge is normally ideal for the case of research and development in various laboratories. The case of if you are centrifuging at a low speed, remember also you might not have achieved, because it requires high speed of centrifugation that is normally is given in gravitational. And if you are using the relative centrifuge force, you have to actually uh, convert for you to get the 100% or above, maybe high yield of DNA. So I think I've answered yours very well. If you centrifuge your sample with low speed, remember you will not achieve the target maybe of the DNA yield you requiring. And if you use the right correct speed for spinning, definitely you will achieve your good yield of DNA. Yeah, thank you.
Thank
Back to
you.
you.
Another question from Frederick Okoth, and the question is, while doing paternity DNA testing, what is the most preferred sample?
Okay, for DNA paternity case, the most preferred sample is is normally the blood sample. And in this case, normally, if in this case is fraternal DNA, the blood sample is okay, is fine, or whichever. But the best yield for you to get the good yield of DNA is normally the blood sample, which is collected from the suspected clients, the claimer or whatever. If the father is claiming to be the father of the child, or the mother is, they are normally taken the sample, and the preferred sample is majorly blood, or whichever case. Even the other specimen is recommended too, but it depends with the method you are using.
Thank you so much for that response. Edna Kurgat is asking, does heat affect DNA yield? Does heat affect DNA yield? Back to you, Dr. Ari.
Yes, thank you very much, Edna. Yes, heat normally affect the DNA, and that is why the normally specification for the storage is normally at negative 80 to negative 20 to maybe or 18 degrees centigrade, because the high heat, as you know, most cases might, the sample might becomes degraded due to high temperature. Thank you. I hope I've answered for Edna.
Very well. Yes, we have this Dixon Musango, and he says, wonderful presentation. That's great, Robert. And Edna has responded. Thanks. I think we are done with the questions that we had for today. So allow me to bring you back, Dr. Rono, so that you can do your parting shot. And you can also tell us in terms of molecular testing and knowledge, where are we going as medical laboratory professionals, and how can we leverage on the different diagnostic techniques, designs, so that we move with the changing dynamics in lab medicine in relation to WHO recommendations and the changes in the world. Thank you.
Yeah, thank you very much, Ada. Thank you also for your very good questions. As far as our sons and extraction is concerned, you remember, and as per the history, the previous history of DNA extraction, we've come from very far since the 1869 by Frederick Miescher, who decided to isolate the DNA from the white blood cells using the alkaline extraction. And we came all the way to 2000, when we became to have automation and high throughput methods, like the use of the magnetic bead-based extraction, and also the spin column technology, whereby this spin column technology has really helped in terms of isolation of the DNA, and also save time, and also it, it's more a bit accurate, and the report normally produced currently is reproducible in our clinical laboratories. And we really applaud the ministry by actually giving us light on ways on how these things are supposed to be done. In most cases, remember also, when the extraction is done, there are various machines that has been introduced for you to achieve the recommended uh, uh, recommended quality assessment DNA molecules. There is that machine called spectrophotometry, which normally guide us on the, before even you proceed to your amplification. This one will show you at what point, or what did you achieve the correct volume of DNA during extraction, and if not, what are we supposed to do. Can we go back to do extraction again? And this, in most cases, the automated extraction method has really helped, because in most cases the automated extraction most cases gives 100% accuracy. And we really appreciate also the scientists currently. There are many facilities currently practicing molecular lab. Since the pandemic of COVID-19, it has really helped. And these methods which has really helped is because of much contribution from most of our colleagues here. So as we go ahead, it's good that we practice more and have CMEs regarding this. We discuss strategies on how these things can be improved, and also how to avoid errors in maybe coming future. So I think that is good. Other, maybe I don't have much more to add there. Maybe we have to actually be keen when actually doing a process of extraction, because this one, in most cases, uh, if people do not follow the right protocol, it might lead you to some few and mistakes which might not be good in laboratory practice. Thank you.
Thank you so much. Thank you so much, Doc, for being able to do for us this presentation. These are many presentations that are so much needed in our profession. With the changing dynamics in lab medicine, we need to go the molecular way so that we can compete internationally. So we really appreciate your coming to LMSK to do a presentation with us. We also thank our participants for turning up in large numbers and attending this webinar. We encourage you to attend more webinars which are yet to come in our subsequent presentations. And so anytime we do a webinar alert, kindly register and plan to attend. On behalf of LMSK, my name is Athay Mari, and I was your moderator today. And so I wish you a good evening, and I hope to see you tomorrow. In case of any complaints that arise from CPD points, we urge you to reach out to the numbers that we normally share. We also urge you to register your complaint with the link that we normally share, and also make an attempt to join our online platforms so that we keep updating one another on the informations that we normally update. Otherwise, thank you and have a good evening. Bye-bye.
Thank you.